Now I'm going to talk briefly about Brightfield microscopes and why we use staining to see the specimens using these scopes. These are the ones that you have in the laboratory, and they'll show you a bright background where the specimens are going to show up as a darker color. And that's because the light goes through or around the specimens and is refracted, so it changes the way the light looks when you see it through the objective lens. There are two kinds of stains that we use to make the differentiation or the color show up better, and they're the cationic stains. These dyes are basically salts. They have a positive and a negatively charged particle that's associated with the salt. It's like sodium chloride, but in this case the color is on one of those molecules. So a cationic dye, the color is on the positive ion, and since bacteria have a lot of proteins and chemicals on their cell surface and inside their cytoplasm that is negatively charged, a cationic dye will color the bacteria by sticking to all of those negative charges. And an anionic dye is going to be a negative ion, so it's going to be repelled by those negative charges on the bacteria, and it will stain the background. So simple stains use cationic dyes, and then of course you can use a negative stain to stain the background so that the vegetative portion of the cell will work. There's one type of capsular stain where you're looking for the capsule, where you stain the vegetative portion of the cell with a color that's on a cationic dye, but you also use an anionic dye. So what happens is the background is stained and the bacteria is stained, but the capsule is not. So you see a clear zone around each individual cell. It's really kind of cool. And the next slides that we'll be talking about will be differential.